Hello and welcome. Today we're going to try to make a very simple application um, that we will add features to later on, but we want to start out bare bones and simple. So this idea my friend had. So there's a card game called War, and there are rules to this game, and it should be fairly simple to implement in command line Python. But let's just review the rules and try to outline a framework and code it and see what happens. Alright, so this is how to play War. Alright, ages 3 and up. Let's hope I can code this. Alright, so the goal is to be the first player to win all 52 cards. That's cool that we have a goal state. You can know that. Deck is divided evenly. Each player gets 26 cards, dealt one at a time, face down. Anyone may deal first. Each player places their stack of cards face down in front of them. Each player turns up a card, and at the same time, and the player with the higher card takes both cards and puts them face down on the bottom of his or her stack. Okay. So I can definitely already think of a good way to do this just using a list. This might be really simple. Alright, if the cards are the same rank, it's war. Okay, so let's start brainstorming here. The general way that I would want to start coding this, I guess, would be to have a loop and then two different players. So let's just start here by saying we have player 1, and they're going to be a list. That's who they are, is their cards. So player 2 is also a list. Now we want to, I think what we want to do is we want to have a loop which plays the game until there's a winner. And so we're going to make a value called winner, and we're going to name it false. And then our loop, we can review Python loops here. There's, obviously a lot of different kinds of loops, but you want to pick the one that's best for your situation. And the for loop, we don't really have a sequence. It's kind of just left open. So we're going to use the while loop here. And basically just say while winner is false. We want to change our text to Python here. All right, so while winner is false, then we're going to play the game. And then if winner is ever true, then we'll exit the game. Okay. We can also make another way to exit the game, but for now, again, we're starting off very simple here. So we're going to leave it this way. Excuse me. All right. So we have 26 cards, or 52 cards total. Each player is going to be dealt 26. Now, the way to handle cards might be a bit difficult, but we could create a deck. So we should probably do that before we go much further. So a deck of cards can be a list, and really we just want every single card that there is, but that's 52 different cards. That's a lot of things to type, but I don't know. Let's just make sure we know what the cards are, all 52 cards. I don't want an image, I just want to know what they are. I'm pretty sure I know the ones, but, Alright, so here's an example set. What we could do as well, since we're like, I don't know, since I'm lame and I don't want to do that much work yet, we could create a deck by starting out with like clubs and like the ace of clubs, the 2 of clubs, 3 of clubs, but I'm really, really lazy. And so instead of doing that, I'm just going to use numbers right now. So what I could do is just have a deck of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops. And you know, I could do it this way, or I could just generate an array of a certain size, I think, to create like a really interesting long game of war. But for right now, because I want to take this simple and build the foundation first, we're just going to make a deck of 10 cards, and each player is going to get 5 of them when we deal the cards up. All right. So we've got both of our players. We have our deck. We have a loop that's going to start the game. Now what we need is to deal the cards to the players, because that's the first step. So in order to do this, it's got to be random, but we need to give each player 5 cards. And that might get interesting. How would we want to do this deal? Because we need to shuffle, well, we could just shuffle the deck and then cut it in half. And there's probably a utility for that. So, Python randomize a list. Let's see if that's a thing that we could do fairly easily. Oh, look at that. Shuffle. That's what we're looking at. All right. And yes, there's ways we could think about this without using that utility. And that's often what you'll be asked in like a coding interview. But because I'm, again, lazy right now, I just want to do this. Apparently, you can straight up do dot shuffle. That is stupidly easy. Okay, so let's make a new thing called, well, yeah, I'm pretty sure you need to assign it to a new variable, but oh well. Shuffle. That's crazy. That's absolutely crazy. Okay, so we have the deck shuffled now. Now what we want to do is split it in half, and no matter what size it is, I want to be able to split this list into 2 other lists. Now, we can create a function for that. And what we would do is we would say we want to get the length of the list. So that's going to be the length, well, yeah, sure. Length of our shuffled deck. So that we're going to split in half and then assign each half to a new list. All right, now how do we do that? We simply, well, let's just do this all in one go here. We're going to take the length and we're going to divide it by 2. And that's going to give us our half. And then we want to assign half of the list to player 1 and the other half to player 2. And I like Googling things because it can give you smarter ways to do it. Yes. So let's see what we get here. All right. Yeah, I guess we will just use a for loop. I was thinking about like if there was some easier to use utility, and there might be, but for now that's fine. So to add to a list, we use the append function. So we're going to say for x in range 0 to half. I don't know if this will work. We are going to append the X value of our shuffled deck to player 1 list. And and then what I want to do after this and before I do anything else is just print player 1. So I want to see what happens. So we're going to go ahead and save this. We're going to make a new folder called war. And here we're going to save it as war.py. And we're going to try it. And it's probably not going to run. That is okay. Because we're learning here. Okay, so we got a problem here. Invalid syntax for the while loop. Oh, that's pretty simple. We're using we're assigning the value as opposed to using the double equal sign, which actually tests for equality. So now we're gonna try. Did I not save it? I thought I did. Invalid syntax. Oh, God, you gotta actually change it in the right spot. That'll do you wrong. I don't really need this to run right now, actually, so let's just ignore that. False is not defined. Really? I thought that Python had true and false data types. Let's make sure that it does or doesn't. Yeah, I thought that there was a false type of data, but maybe not. Oh, it's a capital F. See, it's a little bit picky about these things, but not too bad. Okay, list object has no attribute shuffle. Did they lie to me? Did they? That would make me very sad. What the heck? Looks like you need to import something, I'm guessing. I thought we could just do the list.shuffle, but perhaps not. All right, this will be pretty easy then. So let's go ahead and import random. And then we'll do random.shuffle on the list. Okay. Now we'll run it. Still getting some errors. Okay. Object of none type has no length. I thought it returned but apparently it doesn't return a list object. Maybe it doesn't. Maybe this just straight up changes the deck. So we can try that, and I guess it may actually just change the list. So let's see if that does what we want. Okay, float object cannot be interpreted as integer. What is what is our float? Oh, I'm guessing half is our float object. Really? Why? Ugh. Health. Always takes longer than I think. Okay, so okay, it does. I don't know why it's doing that, but let's make it into an integer. Float cannot be interpreted as an integer. Well, let's make it an integer. Maybe I need to assign it to itself here. So we're going to cast int half on half and give it to itself again. Okay, we got farther. Shuffle deck is not defined. Yeah, because, okay. I changed it. Okay. How far are we in here right now? We are... How long have we been recording? 15 minutes already? Jeez, time flies when you're having problems. Okay. The cool thing is, though, 15 minutes in, some errors, we have a shuffling deck sequence, and that's really like the heart of what we need to have happen. So this is good. So now, what we can do is we can do the other part, which is x in range half to the end of our list, which I guess is like, I don't know how to do that, like to the end. I think it's like -1. I think that's the term for it. We'll find out. Well, no, I don't know. We're gonna find out how to do this the right way. Player 2 dot append, and then we'll use our deck x. No, I don't. Well, no, I don't know, because -1 when you're referencing a list is usually like, I think, the last element. But you know, we'll find out if this works or not, and it may not. Okay, yeah, it's an empty thing there. So let's not do that. Oh, let's just look it up instead of being hard on ourselves. Well, oh, duh. We'll just go half to the length of the list. Shh. That's silly. I don't know why I didn't think of that. Okay. Now let's see what we got here. Sick. Okay, and as we can see, they're not repeating, so it properly shuffled the elements, and it's different each time. So that's really cool. Let's do it again. Yeah. All right. Okay. Framework has been laid out. Now we have our player 1 and player 2, and their decks are shuffled and split, and it's clean. What do we want to do now? We want to play the game. So this is our while loop. Now, what's going to happen is basically we're going to compare the first element of each player's list with each other. And then we're going to take an action where, let's go back to the rules of war really quick. So each player turns up a card at the same time, and the player with a higher card takes both cards and puts them face down on the bottom of their stack. So let's do this. Essentially, it's just, we want to have a loop, though. Well, no, I don't think, let's just do this. If player 1, if their first card is greater than player 2's first card, then player 1 will take both cards. So let's do this situation really quick. Let's also just print out. Well, actually, we'll print it out at the beginning so we can kind of see. We can create some more messages as we go, but let's have them compare the cards, and then if that is the case, we are going to give player 1 both of those cards. But at the end, so what's going to happen is we're going to append player Let's see, what order does it do it? They takes both cards and puts them face down the bottom of the stack. I don't think it matters what order, which is nice. So for the first thing we're going to do is we're going to just add player 2's card to player 1's list, and then we're going to remove it from player 2. List operations, we're going to remove it from player 2, right? Because they're going to lose that card. They're going to lose it off the top of their list here. Index count pop removes the element to give it index. All right, that works pretty well for me. So we're going to give them their card, and player 2 is going to lose that card. Let's make sure we know how to use it. Come on. And just straight up the index. Okay, so we're going to pop the 0. So they're going to lose that. Player 1's going to gain it. Player 1 is also going to gain their own card, but like it's a little bit weird. I don't know if this is the way to do it that's proper, but for now, it doesn't matter because our goal is just to get this built. Later on, we can focus on what we want to change about it. And player 1 is going to essentially lose their own card at that index. Okay, so that's what's going to happen if player 1 has the bigger card. Now, if player 2 has the bigger card, essentially this sequence is going to just be reversed. So you can also probably make this more efficient, but again, that is not the point right now. So player 2 is the winner here. When you stare at a word too long, like the word player, it begins to look incorrect. And that happens to me a lot when I'm coding. Is that a real word? So what we're going to do here is we're just going to simply swap these around. All right, and that should do it. Now, the thing is, if they're equal, that's never going to happen because I didn't make it that way. That's a huge flaw. We can't really play war. But you kind of can in a way. So let's just make sure the program runs. Because right now we're not doing any comparison. Okay. List index out of range. If player 1, wonder what's wrong with that. Wonder why the index is out of range. I mean, it shouldn't be, right? We have player 1 and player 2 as lists, and they're displaying the list. It might be that might be the whole loop thing. So let's have it print out something for each round. You know, that would be nice. So a round counter is going to equal 0. I'll just start at 1. Whatever. Print round, and then we're going to print round counter. All right. And then after all this happens, we're going to, I don't know if we can do plus plus in the Python universe. That's something to look up. But for now, we're just going to increment it and call it a day. So now we'll try running it. Oh, okay. So it played quite a few rounds before it broke. That's interesting. All right. So we are playing each round. And of course, it makes sense that we played all the rounds, and then there's no more cards left for one of the players, and they lost. So Now, here's what we could do. We can also start printing. So if player 1 had the greater card, here we'll say print player 1 wins. And if player 2 has a bigger card, we'll say player 2 wins. Alright. So this looks fairly good. Like it looks like it's not too broken and that it's fairly random. And that is really good. Now, obviously, we didn't really fully implement war yet. I'm at 25 minutes. Not too bad, you know. Not great, but not too bad for 25 minutes. We've got a working shuffle system. We've got decks of cards, and we're able to compare them. Now, why isn't it war? Partially because there's never going to be a conflict, because in the deck I gave, there's no repeating values. If there were, then we have to handle that, and that's a whole nother situation. But of course, that's the whole game of war. Is if they're the same rank, then each player turns up one face card, or turns one face. Let's see. Each player turns up one card face down, one card face up. The player with the higher cards takes both piles. If the turned up cards are the same rank. Okay, so it's a little addition on the game essentially. And that deals with when you have the same cards and it makes it more exciting. But the basic fundamental game of war is right here, and we can add that feature on next time. We kind of want to stop it from breaking at the end, you know, and we also want to actually assign our winner. So how would we do that? Let's think about this real quick here. So at the end it says if player 1. So it looks like player 2 won a lot. So I'm gonna guess that player 1 doesn't have any more cards in this instance. So we need to create a situation where if there's no more cards, we should check. So if player 1, basically if they're empty, and I think there's a way to check that. Well, we could just say the length is 0. So if we'll check every round, if the length of player 1 is, oops, if that's 0, then we will print player 2 wins the game, not just a match. And we will set our winner to true. Okay, and then we'll also perform this check for player 2. If they're at 0, then player 1 wins the game, and blah, blah. Okay, that hopefully should fix our error. Let's see what happens. We try to, oh dear, try to play a match. Oh, it's still giving me an error. What? Round 13? Excuse me? Woo. Okay, what's wrong here? List index out of range again. Oh, it's still trying to go through with the loop, that's why. We want to break out of the loop. So setting it to true is cool and all that, but the problem is the loop is still going to happen regardless. And we could just check these things at the end instead of the beginning of the round. Let's do that. That would make more sense. So we're gonna paste it right down at the end here. All right, now let's see if that solves our problem. Apparently not. Interesting. So in this instance, after 5 rounds of player 1 winning, it checked and said, oh, player 2, do you have any cards? And they didn't. A check should have been performed, though, that the length of the list was 0. And then winner should have been set as true. And we should have not played the game anymore. So I feel like these checks didn't happen, or they didn't happen correctly. Because in this instance, it should say if length of player 2, if the length of the list is 0, then player 1 wins the game. Now maybe that's not how we check for an empty list. Maybe it has a default length or something. So let's search that, and we can probably close out a lot of these. Because my 4 gigs of RAM is dying here. If not A. All right, we can try that. But I feel like the length of an empty list should work. And we could check to see if, how to check for an empty list, I think. But let's just try it. I don't know. Let's see. Well, it worked. So it looks like the length of an empty list might not be entirely accurate. I don't know why I said equals 0. It's just if not. I think yeah. Oops. We did not fix the problem yet. Okay. Try that again. Just ignore what you saw there. Okay, that looks a bit more right. Player 2 wins the game. Okay. Yep, so that looks like... I want to see player 1 win the game sometime. Ooh, error. Player 1 won, but... See, in line 31, there was an issue. Again, what the heck? It's interesting how you can think that your application is working, even though you do have a lot of debugging still to do. So, in this instance, it was out of range again. Why? So, player 2, apparently, player 2 didn't have any cards and we couldn't check, but if it didn't have any cards, it should have exited the game. Situations like this can be a little bit difficult to debug, and it's also hard to make this happen again when it's random. But let's well, okay. The list index is out of range, so it can't even look at the first element of player 2 because player 2's list is empty. We shouldn't be looking at the list. We should be only looking at the list if it had something in it. And so after everything happens, this is where we check for it. And if